What do you mean by information? First of all, okay. So the purpose of communication system is to carry information, bearing signals from one place to other place. Okay, so one place is nothing but you can say called source or transmitter, and other place means receiver. Generally, information. See, the communication system. What will happen? Suppose this is we have a source, and just data will be transmits the receiver, and so source or transmitter. You can say this one transmitter. Then this is a receiver. Okay, basically information will be the communication will be happen. Okay, so in this information will be carried, right? Information is carried in this. So basically it is happened with the source to destination through over a particular communication channel. Okay, so make the point better. The purpose of a communication system is to carry information bearing as a classes bearing signals and signals from one place to one place means if I want to write basically called source, right? Or transmitter you can call transmitter to another place or other place. Other place basically it is called receiver over a communication channel. Over a communication channel. Okay, so this is like this: source to destination or receiver, source and it is the destination, a transmitter or receiver over a communication channel. Information will be carried or information will be transferred. Okay, let us see the introduction. Let us see this. Okay, information, basic idea of information. Okay. Information is nothing but message. Okay, so I'm giving certain information. That is nothing but a message regarding about today's timetable or your class status or child syllabus status or new fee reception, exam fee last date. That all are nothing but I'm giving information. Nothing but I'm transferring a message to you, isn't it? Or not? So basically, information can be, it is an idea or a message or intelligence. Basically, these words can be used in the information theory. Okay. So information, it is, if I say, it is the intelligence, I can say, gens are idea, ideas are messages. Basically, we can use messages. This word messages in information theory. Okay. So information is nothing but what? Carrying carrying some message, transferring some message, or ideas, or intelligence. Okay, all these words, basic words used as a information in information theory. Okay, so basically, messages are called what about? So basically, the messages are commonly called in information theory, commonly called symbols or events. Okay, so message is basically called symbols or events. Okay, so why it is called symbols and events? Let us see, for example, if I take as a message, if I want to take as a message, so information basically we are using the word message, right? So if I take message, so what are the forms? Then messages are basically electrical, which is nothing but, for example, in electrical, voltage and current. Okay, is a message, right? Or information, you can say. Basically, in electrical, information passed through what? Voltage or current, isn't it? Right. Next is speech, or we can say voice, right? Speech, voice, and this is the one of the message. Okay, so I'm giving a lecture here. So my voice is nothing but a message for you, isn't it or not? Right. Next. So what forms basically message consist of? You are sending a message as a in festivals or some other times. You are sending pictures. Okay, that is nothing but a message also, right? So pictures or images is nothing but a information source. Information you're sending, there is nothing but a message. And another one, nowadays very popular, messages are sending in terms of audio and video. That is also message, right? So I can say videos and audio, videos and audios. So these are all are comes under basically information sources, right? So messages can be videos, audio, electrical, in all different technology. Sorry, in different areas. Information is nothing but message. Our messages are nothing but information sources. Okay, right. So, information is transmitted from let us discuss in terms of like a diagram. Then in this point is transmitted from source to destination and discussed in the book. Okay, so if I take this one as a block diagram representation, then I can say information source. I can say this is information source through where transmitter. So I can say transmitter. Then what will you get about? Then encoder. The transmission will be encoding, right? So encoder will be there. Then you will get I will write here channel. After that, you will get channel, this one, continuity. And from that, you will again encoder. No? So you need to do decoder. Then becomes transmitter, no? The receiver. Then the last one is destination. Okay, so these are the areas basically the information is transmitted through like this. So from source to destination. Okay, so receiver, up to receiver, you can say up to receiver. If you take transmit information source is transmitted to up to receiver. So this entire part, encoding and decoding, this part basically, this whatever the part is called source, and this part is called a destination. Okay, through our communication channel. Okay, so basic information is transmitted from transmitter to the source to destination, or transmitted to from source and received at destination. Okay, so basic idea of information, right? Let us say information. If I take one example, see, suppose I have messages, say x0, x1, x2, so on, say xn. Then probability of these messages, if I take p0, p1, p2, so on, up to say pm, for example, then the total. So the total probability is how much? Always it will be 1. Therefore, this can be represented if I take k is equal to 0 to n or m, and the probability of pk is equal to all the time is 1. We know that if number of messages, if I consider this one information or events, that's why I said these are the events, isn't it? Or symbols or components, elements. If I take the probability of over there, then it becomes overall will be, as we know, it is 1. Okay, now another one simple example to understand information theory or information or message. If I take examples, let us see. Example, the first one, now I can say sun rises from the east. So how many know this one, Amma? Sun rises from the east, isn't it? Are you surprised? Anyone are surprised? No, because you know that sun all the time rises from east. There is no surprise in the message. Whatever I given, whatever the information I given, sun rises from the east. You never surprised because you know already that it will be happened every day. So for this case, what is that? Probability is 1 because it happens. You know that. So maximum probability. How when I take a maximum probability, there is a confidence of occurrence. There is a compulsory in occurrence. Okay. So I can say occurrence is compulsory or must. Then you said that the probability is high. Then what about information? Information is equal to 0. So which means here, sun, I want to message you something that sun rises from the east. No one said that this is a nothing, no information is given. So when the probability is high, the information is 0. Remember this. Okay, so even though I given, which is happened daily, so no one can surprise, everyone knows this one. So this happens every day. So probability is high, and the information whatever I given is very low, zero. No one is considered that. Everyone knows this one. Nothing new in this. So you won't surprise. Then information will be low. Remember this. If I take another example, second one. Are you able to understand, friends? Please respond here. Am I audible? అమ్మా వినబడట్లేదమ్మా నాకు. 1 minute. Increase voice. Okay, na? Am I audible? I will check once with my device. Am I audible? Okay, right. Now, second one. If I say India got independence, India got independence in 1947. So this message I would like to give today. Then are you going to surprise? Because already you know every Independence Day of August 15, you are celebrating our Independence Day. So everyone knows that. No one will surprise this by listening this. So you consider this as a message, nothing, no message. So for this one also, I can say the probability is high, already known, and the information is zero, low. Information is low. Okay, students, got my point? These are the past values because of past, you know everything, right? Okay, let us see another one. Third one. Say you will get 2 mails in the, for example, in the next hour. In the, I can say, next hour. Next hour, for example. You will get the mail. I am giving the message as a class in charge or whatever, as a faculty of yours. You will get 2 mails in the next hour. In this case, tell me, in this case, still, even though it is in future, you will think that as a faculty, I am giving the information means it is almost done, almost correct. Then I can say I will give for this one approximately the probability will be 0.8 and information will be still low. Okay, because of probability is high, still low means some information is there. Okay, but information is still low, not zero, but still it is low, remaining point to something. Okay, so you will get 2 mails the next hour said. So probability is 0.8, and you will say it is not a big message. So maybe you will take it as a consideration that you will get mail and you won't check immediately. Maybe you will wait for half an hour or 1 hour, or the end of the day you will go to check the mails. Right? Therefore, the information is whichever I given is still it is low. Right? Getting my point, friends? Fourth one. Suppose say the prime minister will come to, for example, your home by tomorrow. Next information I'm giving, the prime minister will come to your home by tomorrow. Now you will surprise definitely. It's a big thing. India's Prime Minister is going to visit your home. It's a really surprise and wonder. Not wonder, it's surprise. Big surprise. Okay. Then you will say that if I give this information, you feel that the probability will be very less. Prime Minister. చూద్దాంలే వస్తాడో రాడో. Okay. So like that you will feel. Okay. So probability is very less, very, very less. Because the Prime Minister is a very busy person taking care of entire nation. So visiting your home means it's a very big thing, really. So you'll feel that what is the probability? You'll feel that very, very, very less. So I given here 2 zeros, but it may be 3, 4 zeros still, 0.00001. At that point, what is the information amount? So whichever information I given to you is very high. Whichever information is given to very huge information, because you will surprise, you'll wonder, because Prime Minister is going to visit your home today, by tomorrow, whatever. So information is higher, but probability is very less, 0.0001. You'll feel like that only. But what are the information? That information is very important and very high information. Got my points? Students, these are important to understand the information. So what type of information basically? Next, another one. Rain, not rain, if you, it will snow in Hyderabad in next winter. So not now, upcoming winter, for example. It will be snow in the Hyderabad in next winter, for example. What do you feel? What do you feel, Amma? Then, as of now, I didn't saw snow in Hyderabad. So probability is what, Amma? Low chances, very low chances. But whatever the information which I given to, which will surprise you, the information still is high. What my point? Like this. So what I want to convey here in these examples is, if I say information, if I take like in the above messages, information of messages, this one is equal to, or sorry, not is it, it's directly proportional to 1 by x. Right? What my point? This is a probability. P is a probability. I is the information here. So information of events or messages, whatever, are directly proportional to 1 by probability of events, particular events, that particular events. Okay. So when it is increases, then this will be decreases. When it is decreases, then this will be increases. So same example, check it out here. I've gone through same. So when this become a high, and this become a low, and this become a high, and this become a low, like that everywhere. Same thing. If I said, still if I said 50-50 chance also there, still if I say in the next Wednesday, upcoming Wednesday is a holiday for you, or Sunday is a holiday for you, you will think that 50-50 chances. Say that in that case, if you take probability is 0.5 off, then information is also 50% is off, like that. Okay. So few students will be think that yes, next Sunday is a holiday, but few things there is a maybe working day again, like that, or Sunday or Saturday, whatever. Okay. So this is the theory of information with the probability. Okay, students. Once we if you know the what is information, then we can move easily further. Am I audible? మా వినబడుతుందా? రెస్పాండ్ అవ్వండి మా ఎవరైనా, ఎందుకంటే వాయిస్ ఓవర్. Is it okay? Let me know, please. Right. Now, next step, next we'll see measure of information, or I can say amount of information. Okay, so let us see this measure of information or amount of information. Let us see this. Okay, now let us consider a communication system with m number of messages, number of messages, or we can say messages or events, whatever. Okay, like A1, A2, A3, so on, AM. Okay, and their corresponding probabilities of occurrence, you can say better. Okay, probabilities of occurrences are, say, probability of A1, probability of A2, probability of A3, so on, probability of AM, because A here event, right? And we know that probability of A1 plus probability of A2 plus probability of A3 plus so on, probability of AM is equal to how much, Amma? Anyone? The total probability is always 1, right? If I consider all the events with their probabilities must be equal to 1. If all are occurred means it must be 1, we know that. Okay, therefore if the message is AI, I'm taking instead of 1, 2, 3 and AI, then where I is equal to how much here? 1, 2, 3, so on up to M. Okay, therefore the amount of information is denoted by I of AI, because AI is the events here or messages here, right? So therefore what you can represent here, I of AI, this is a standard notation given by books. Okay, so this will be taken as log base 2 of probability of AI. Okay, I will go through once again. Amount of message or measure of information will be taken as considering here communication system with m number of events or messages are A1 to AN, then the corresponding probabilities occurrences will be, if I take probability of A1, A2 up to AN, and we know that sum of the probabilities must be equal to 1 with their events. If the message, if the message is AI, where I is equal to 1 to M, therefore the amount of information is generated by AI. AI is equal to log 2 1 by probability of AI. Now, how can calculate log 2? I can give that information also for you. So basically, the calculation of log 2 is, how can you calculate Amma? Log, for example, log 2 of x, how will you calculate? Log x base 10, చెప్పండి, log 2 base 10. Okay, so units of information is what in this case? So this is also, I can calculate log 2, this one, log 2 of x. Okay, so log 2 of x, can calculate log x divided by log 2 with the base 10. Okay, so units of information, you know already that information is bit. Unit of information will be, remember, it is bit, bits. Okay, is it okay, dear students? Okay, let us see still different units also used for information of different events. So I can give that also better. Different units, can say units used for amount of information. AI, this is A. This is AI. Messages or events are 1 to M. Okay, AI. I'll give small table so that can easy to remember. So let us take one small table. Okay. Better because we are going to remember. Base of the algorithm, base of the logarithm, base of the logarithm, I can say it is a base. So depend on the base. Okay, so what are the units you can see? Okay, unit used for I of information. Okay, so let us see that what are they. The first one is, if I use b equal to 2, base 2, just now I given base 2, what is the unit sum? Bit, right? So for base 2, it bit. Okay, so basically this is used to binary digits, right? By bit means what? Binary digit. Okay, second one, we have base 10. Base 10 is for what? Hartley. So units are Hartley or decit. Decit. Okay, so this is used for decimal values. Decimal units, you can say. Decit. And the third one, base, like you need to take E. So E is basically what this one is? Natural unit, right? So base is nothing but what? It is a natural unit. Okay. So different type of logarithms. Okay. The bases, these are 3 bases here. The information units are For base 2, it's said to be bits. Base 10, it's said to be hotly or decit. Base E, it's the natural units. Okay? Is it okay, students? Are you following? Now, still we have time. So let us go with some properties of information, right? So I would like to take properties of information. Let us see the properties of information. Right, the first one. Observe carefully. Properties are very, very important. Okay, the first one. More uncertainty uncertainty about the message about the message that is more information that is the information is more, I can say better, that is information is more. See here, more uncertainty about the message, the information is more. Okay. What do you mean by uncertainty, Amma? Already we completed all the theory of probability. Certainty or uncertainty, occurrence or non-occurrence, right? If you don't know the future value, if you don't know the future value, then it is become uncertainty. An event tomorrow, our PTSP class is going to be certainty or uncertainty. It is going to happen or may not be happen, or occurred or may not be occurred. So remember, simple word, more uncertainty about the message than the information is more. Simple. Okay. So I given the example also. By tomorrow, the Prime Minister is going to visit your house. Then it means what, Amma? Visit your home. It means what? There is a lot of uncertainty will be there. Okay. So therefore, uncertainty in the message basically. Therefore, you said that information is more. It's a big information. Like, let us try to prove with one example. If I say, like to take A1 is equal to 1 by 4 and say A2 is 3 by 4. Okay. Then for uncertainty, A1 is greater than A2. Sorry. Greater than A2 because lesser probability have the more information. Okay. So see here, uncertainty of A1 is greater than uncertainty of A2. We know this. Okay. If I take this in terms of information, information A1 is greater than information A2. Yes. Let us try to solve this one. Let us try to solve this one. If I take A1, so log 2, what are the log 2 we need to calculate? Log 2 divided by probability of A1. Right. So what is the A1 number? Log 2 1 by 1 by A1 is 1 by 4. Right? 1 by 4. Then 0.25 can write anyway, right? So this become, if we take the above one, so log 2 will become a 4, right? How can we present this one? Logs. So log 2 square can I write 4, right? And if I take still this one, so how much this one? 2 log 2, 2, right? Log 2 is log 2, 2. And this power will taken here as per rules of logarithm. So this becomes what? 2, 2 will get cancelled. So we get not get cancelled, sorry. It becomes a 1. Base, when base equal to number log, then it become a 1. This value becomes 1. Okay, so therefore it becomes is equal to. Okay. Right, let us see this one, which is the more information. Again, here also, if I would like to take A2 is equal to information of A2 log 2 property of A2. Okay, now if I take this one 3 by 4, so log 2 1 by 3 by 4. Okay. Okay, just calculate this one. Log 2. So it becomes what? 4 by 3, right? If we go upside, this become a 4 by 3. Sorry. So as per logarithm, if I take this one as a, in terms of base, then just now I given formula 4 by 3 is a base 10 divided by log log 2 base 10. The above formula. What is that? If log 2 of x is taken, means what? Log x divided by base 10 log 2 base 10. Okay, as per logarithms, one of the formula, right? So I took this one. So this becomes what? This becomes, if you calculate these two values, you'll get, I'm writing here, already solved, 0.41. Therefore, with this conclusion, 2 is greater than 0.415. Okay, so hence it is proved, right? As per our terminology, if there is uncertainty is more greater, then the information also greater. Example, hence prove this example. Okay, with this example, with the two information, okay, if I take information is more. Okay, so therefore, this two is satisfied here. 2 is always greater than 0.4. Okay, what my point? This is a property number 1. Right. I'm giving with examples so that you can able to understand. Second property of information. So I will say property 2. Property 2. Okay. Receiver message being transmitted. Receiver, sorry. If receiver knows message, if receiver knows the message being transmitted, what happened, right? This is being transmitted, message being transmitted, then the information is 0. Then the information is 0. Receiver knows the message being transmitted, then the information is 0. Okay, if he knows, already I given few examples, if you know the past value, then the information is 0. India got independence in 1947. I given message, I posted message for you. second year B students, then what do you feel? You don't feel that whatever the information I given is valuable. Okay, because already you know this is the past value. So receiver, if receiver knows the message being transmitted, then the information is taken as a 0. Okay, very low, right? Let us see that also. For example, information receiver knows that if I take one example, a receiver knows the information, for example, say A1, I'm naming A1. So property A1 is occurred already. This A1 is that particular information that, for example, say this information, if I'm naming it, this information in India got independence in 1947. India got independence in 1947. For example, A1 is that message. Already you know the information in transform. Then the property is what? High. Okay, occurred, already happened. You know that. So you know that this one, right? Therefore, how can you justify? Then the information is 0. Then I of A1 information is equal to what amount formula we have? So with proof I want to show you with formula A1. Therefore, this one will be taken as calculate log 2 is a high, probability is taken high. So 1 by 1, okay, substituted. Then this becomes what? I can say log 1 base 10 divided by log 10, sorry, log 2, this one, log 2 base 10 as per our formula, then this will be 0. Because log 1 is 0 as per with base 10. So this is 0. So what I get information in this case? I of A1 is 0. If we know, receiver knows the information being transmitted, that is the probability is very high, almost very high, okay, then information will be, you will get 0. Is it okay, students? Are you able to understand? Okay, so 45, let us complete another uh, properties. I'm going slow initially, unit introduction, this part, because you must know the information. What is the basic information? Right? Next property. Property number 3. So third one. Property 3. Okay. Now we'll go a little bit faster here. Time is up to another 10 minutes. I would like to take, not up to 45, up to 50, if you permits. If I1 is the information of message is A1 and I2 of A2, then I1 plus I2 is the combined information by events A1 and A2. Don't confuse them here. Already know A1 means what? Event or experiment, whatever. I means information. Okay. So then if I1 is the information of message A1, okay, event or message you can say. I2 of A2, then I1 plus I2 is the combined information by from A1 and A2. Let us go with small proof. Not a proof, example I can take. A small example. Right. So I1 is information I'm writing as an info of A1. Then I2 is information of A2. Okay, so combinedly it will taken as a I1 plus I2 in the above, right? That is the meaning of the theory property. Okay, let us. So I'm naming it I1 is equal to log 2 1 by probability of A1, and I2 is equal to what? Log 2, that is not log 2, base 2, that is right, log 1 by P of A2 of base 2. You can call like that. Okay. So in this case, since the above messages A1 and A2 are independent, so separately is given. It is transmitted by A1, I2 is transmitted of information of A2 like that. So they are independent. Okay. So composite probability, if I take log 2, what is that? Sorry, where initially you would like to write this one, is equal to what? Probability of A1 into probability of A2. Okay, the comma conditional probability is what, Amma? If events are independent, then it's become a product, right? No need to recall the things. Already you know that. Therefore, if I say I1 comma 2 or I1 plus 2, whatever the thing, I named it like this. Okay, log 2 probability of 1 by P of A1. I'm substituting here the product P of A2. Okay, otherwise this name it as 1 comma 2 better as of your knowledge. Okay, so this one base 2. So this can be, I'm writing separately, probability of A1 into 1 by probability of A2. You must know all the logarithm rules. Okay, when these are products, the logs will be summation. So I can write this one, probability of A1 plus base 2 log base 2 probability of P of A2, right? Okay. Then from 1 and 2, this one is what? In the above I given, right? Log 2 probability of A1 is nothing but what? See here, this is I1, right? And this is I2. Okay. So therefore, I1 comma 2 or this if you want, you can take I1 plus I2 is nothing but I1 comma 2. I represented like this. Okay, so this becomes, so I'm writing anyway here. So this becomes what? I1 plus this becomes what? I2. Okay. Hence it is proved. Hence it is proved. Okay. If you want still, where I1 is equal to log 1 by P of A1 base 2 and I2 where log 1 by P of A2 base 2. Okay. So this is the third property. Let us continue with in the next class. And remember, whatever the formulas I'm using here, this one, what is that amount? Please go through logarithm xy. If log xy is equal to, how can you represent this one? Log x plus log y. As per this one, okay. I gone through this one. You know all these properties. When this is a product, xy represented as a log x plus log y. So that's why I taken like this summation of these two. Okay, right. So any query students here? I would like to